let's knock this homework out. You've got 1 through 16, 19, 20, and 35. And 1 through 6, it says, determine whether the relation is a function. For it to be a function, I need one output for every input, okay? So one of the things I'm going to look for is, do I have the same number representing x in any of these? Well, I see there's a 1, a 2, a 3, a 4, and a 5. So that means no number is duplicated, all right? And just so you understand, every one of these values is represented by x, y. X is the input, y is the output. So as long as x always has one output, I'm good. In this case, there's only one number coming as an output for each of these different x's. That tells me this is a function. Each input has exactly one output. Number 2 is for you to do. And I have number 3. Number 3, I look at the input. It's x. I notice that 2 has an output of 3 or 2. That goes against the rule that each input has exactly one output. This is 2 different outputs. Imagine putting clothes in a washing machine. You put in the soap just like you're supposed to. But sometimes your clothes turn out washed, and the other times they turn out ripped. You see what I'm saying? You want one output for each input. So in this case, this is not a function. The input 2 has 2 outputs. All right, number 4 is for you to do. Number 5 is for me to do. On number 5, I see that I have the number 16 here twice and the number 1 here twice. That's an instant red flag. Now, as long as the same number is represented for both 1 and 16, I'm fine. But you'll notice over here, I've got 16 is -2, 16 is 2. That tells me 16 has 2 different outputs. We also have 1 over here that has an output of -1 or 1. That tells me again, 1 has an output of -1 or 1. That's 2 different outputs. So this is not a function. All right, number 6 is for you to do. And I have number 7. On number 7, the function test for a graph is, do I have 2 points that make a vertical line? In other words, for every x value, I can only have one y value. And you see over here, for number 1, I have an output of 6. For number 2, I have one output of 3. For number 3, I have one output of 4. For number 4, I have one output of 1. For number 5, I have one output of 4. As you can see, there's only one output for each input. 7 is a function. No vertical line can be drawn through more than one point. Number 9, this is not a function. I can see that automatically because, well, even though number 1 has one output of 3, number 2 has an output of 2 or 4. That's 2 different outputs for the input of x. Heck, even number 3 has an output of 1 and 5. And if I get down to it, number 4 even has an output of 4 and 6. This does not pass the vertical line test. I have a vertical line here, I have a vertical line here, and I have a vertical line here. This is not a function. All right, number 8 and 10 were for you to do. I've got number 11. It says find the domain and the range. Well, the domain is all the values, all the x coordinates here that cross through x, okay? So this one would be a coordinate of, and I'm just going to give an example here. This would be -2, right? And then the y value would be -2 as well. Over here, remember, we're looking at all the possible x's. So we got -2. Over here, this one would be -1 and 0. So this would be -1. So far I know -2 is part of my domain. -1 is part of my domain. Heck, even this one here has x value of 0. That's part of my domain. This dot has an x value of 1, so that'll be part of my domain, and this one too. So my domain is going to be -2, -1, 0, 1, and 2. But my range is my y values. And you'll notice that my y values are quite different. I have a y value of -2 down here. Then I'm going to have a y value of 0 and a y value of 2. And that's it. So my domain is -2, -1, 0, 1, and 2. And my range is -2, 0, and 2. All right, let's look at number 13. Well, on this one, I have a, remember, we're going to look at all the x values. I've got -4, I got -3, -2, I've got -1, I've got 0, I got 1, and I've even got 2. My range is quite different, though. My range is going to be 2. I'm just going to list them here. It's also going to be 3. And I imagine it's even going to be 4. Well, you know, come to think of it, I mean, I would say all this, but I'm looking at the dots here, and if they just go by the dots, I guess it's really just going to be 3 and 6. So what they're doing is showing all of these in the value of inequalities, okay? And this is a great way to demonstrate everything that it's encompassing. So let me just go ahead and pop this off like that. We see the domain is all the way, remember, x is going to be to -4. It's going to be bigger than -4, right? But it's going to be less than 2. The range is going to be at a minimum 2 and at the maximum 6. Okay, so that means that y is going to be greater than 2 and less than or equal to 6. Okay, time to go to number, well, let's see what's the next one on our list here. Sorry, kind of gave it away. 15 says the number of quarters you put in a parking meter and the amount of time on the meter. So it says in exercise 15 to 16, identify the independent and the dependent variables. And as you quite imagine, if it says the number of quarters you put in a parking meter and the amount of time, well, the independent variable is the number of quarters, okay? It's independent. And the dependent variable is the amount of time, okay? So I know I'm gonna put in quarters into this thing, but depending, right, on the amount of time, it's going to go ahead and that's going to go ahead and play a factor on how much time I'm able to have, right? I might have a whole bunch of quarters, but the amount of quarters, right? The amount of quarters is going to tell me how much time I can go ahead and park there. 16 is for you to do. Let's see, number 19 says in 19 and 20, describe, correct the error in the statement about the relation shown in the table, all right? And the relation is a function because each input is paired with exactly one output. Look, 1 has an output of 6.5, 2, 7.5, 3, 8.5, 4, 6.5, 5, 9.5. Now, some of you might think, Mr. Mendez, 1 and 4 have the same output, but remember what it means to be a function. Each input can only have one output. You can have the same output for 2 different inputs, all right? And so that's why this is a function. All right, number 35. Which of the following values of x and y make the relation a function? Select all that apply. Well, we know A, C, and D. Okay, let's find out why. Now, they gave us this set of numbers here, these different coordinates, okay? And they're saying which of the following of x and y make the relation a function. So if x, and let's just look over here, is -3, okay? Then it says y would be -4. If x was -3, y would be -4. So this says y equals 0. And I'm sorry, I had to look at this twice, to be honest with you, to try to understand what they were doing here. I thought at first they were trying to put these as the value, and I realized at the end that they have an x and y value over here. And what they're doing is saying these values would be placed here. So, okay, let's look at this carefully. This was -4 and 0. There's not another -4 over here, right? So that would be fine. Each one of these is a different x value and has a different one output. For C, if this was 5, there's no number 5 for an x value here. So again, each input is going to have one output. If x was 2, again, there's no +2 over here, which means each x input would have one output. But watch B now. If B was 1, we have an x value of 1 here, and it already says y would be 2. So if y for this one would be -2, I would have two different outputs, and that's why B is incorrect. I'm sorry, kind of misunderstood the question here and had to look at it twice, but that's the last one. The rest are for you to do. We'll be in class to go ahead and grade. Good luck, and I'll see you tomorrow.